So let me start with the important topic in mass storage system, which is called as RAID. So RAID structure. What is the expansion of RAID? Is redundant array of inexpensive disk, which is actually multiple disk drives, which provides reliability via redundancy. Redundancy means what? A repetition. Which increase the mean time to failure, mean time to repair, which means exposure time when another failure could cause data loss. Mean time to data loss, which is based on above factors. Here they have given the example as if mirrored disk fail independently, consider disk with 13,000 mean time to failure and 10-hour mean time to repair. So disk stripping, which uses a group of disk as one storage unit. RAID, which is actually arranged into 6 different levels. RAID 1, RAID 2, 3, 4, 5 and 6. The first level is called as mirroring or shadowing, which keeps duplicate of each disk. And stripped mirror, that is RAID 1, or mirrored strips RAID 0 plus 1, which provides high performance and high reliability. And block interleaved parity, which is RAID 4, 5 and 6, which uses much less redundancy. RAID within a storage array can still fail if the array fails, so automatic replication of the data between arrays is common. So they are saying as frequently a small number of hard spare disks are left unallocated, automatically replacing a failed disk and having data rebuilt onto them. RAID 0, which is non-redundant stripping. RAID 1, which is mirror disk. RAID 2, mirror style error correcting codes. RAID 3, bit interleaved parity. And RAID 4, block interleaved parity. And RAID 5, block interleaved distributed parity. And RAID 6, redundancy. So this is actually first thing, that is RAID 0, non-redundant stripping, and RAID 1, mirrored disk. Other features of RAID are, which is regardless of where RAID implemented, other useful features can be added. Snapshot we are using here, which is a view of file system before a set of changes takes place. Replication is automatic duplication of writes between separate sites. Can be synchronous and asynchronous. Hot spare disk is unused, automatically used by RAID production if a disk fails to replace the failed disk and rebuild the RAID set if possible. Decreases mean time to repair. Extension. RAID alone does not prevent or detect data corruption or other errors, just like disk failures. Solaris ZFS adds checksum as how we are using it in networking of all data and metadata. ZFS also removes volumes, partitions, that means a disk allocated in pools, file system with a pool share. That pool use and release space like malloc and free memory allocation, and which releases calls. So ZFS checksums for all metadata and data. We have address 1, address 2, checksum memory, and here we have metablock 2, and in here metablock 2 we have the address of 1. Traditional and pooled storage. This is the traditional volume and file system. We have a number of file system where it can be stored in a volume of data, database. Just this ZFS and pooled storage. So this is the explanation for RAID, that is redundancy, array of inexpensive disk. Here we saw about RAID parity bits, mean 6 different levels of RAID: 0, 1, 2, 3, 4, 5 and 6. 0 plus 1 or 1 plus 0, they are called non-redundant or mirrored disk. RAID 4, 5 and 6 are called block interleaved parity. So that's all about RAID model. Thank you.